What's going on, guys? Just a short little video of our thermoelectric cooling system that we put together and are testing for implementation into our senior design project. So basically what we're trying to do is reduce the temperature of a patient's breath from about 35 degrees Celsius to 5 degrees Celsius. And we're looking to do this so that temperature difference is going to allow the breath to condensate, or a portion of it. So in the condensate that we collect, there will be trace chemicals from the lungs that'll kind of give us an indication of the inflammation of the lungs. The more chemicals, the more inflammation. So we can relate this this amount of these chemicals and inflammation in the lungs to the medicine they're taking, so we can see if a patient's medication is actually reducing the inflammation in their lungs or not changing it at all. So we can see if they're getting better or worse, basically. That's pretty much what we're trying to do, but the actual system here, it relies on a Peltier module. This will be what really allows for that temperature decrease. We'll have a nice tubing system that runs all throughout. It'll pass over these modules to cool the breath. But this is basically a device that takes electrical energy and converts it into a thermal gradient. So it's really cool. It has about 127 P&N junctions in here. Basically just removes heat from one side and displaces it towards the other. So one side will get really cold, one side will get really hot. And it's kind of limited by a max temperature difference. That's why we have this heat sink right here on our actual test model here, so we can remove a lot of heat from the hot side. And we took this out of a computer, and it has a fan, so we can kind of force convection over the heat sink to keep it as low as possible, so we can really drive down the temperature of this cold side right here. And as you can see, there's a little drop of Coke on here. We're going to try and freeze that in a second. So here's our multimeter stuck inside this little boat shoe right here. So this little Sperry holding our multimeter, you can see it should be about 0. It's pretty much 0. It's 0.1 volts. The system's off right now. So yeah, let's turn this bad boy on, and well, actually let's take a few temperature readings first and see what we get. So trusty little IR thermometer here. We have about 70 degrees on the Fahrenheit, that is, on the table right here. Put that in Celsius, about 20 degrees Celsius. So let's get the surface of this. It's looking at a little warmer, 78 degrees Fahrenheit, about 25 degrees Celsius. So what we'll do is we'll flip this on. It's pretty much set on, this is the base voltage right here, 0.75. Never really gets to 0, but you can see the amps are at 0, so there's no power running through this right now. The temperature hasn't changed. So what we'll do is we'll turn this up. We'll try and maintain about 10 volts. The max on this model is about 12. So as we turn this up, you can hear the fan kick on. We'll do about 10.4. You can see, it's kind of hard to see, the amps go up to about 6 or 7, so we're moving about 60 watts of heat from one side of this to the other. So let's take a new temperature reading and see what we get. 20 degrees Celsius on the table like we had before. 68 degrees Fahrenheit. So let's do it over the module. You can see see a nice drop in temperature there. 18 degrees Fahrenheit. Negative 7 degrees Celsius. That's pretty low. As you know, water freezes at 0 degrees Celsius, so theoretically this would start freezing the Coke. So as you can see, the Coke's kind of starting to harden up. You can see it kind of go through a phase change. That's basically what we're doing here, just trying to prove how cold this thing can get. So as you saw, it got pretty cold. As we turn this off, it'll go right back to room temperature, so you can probably see this Coke start to disperse a little bit. It's kind of freezing up right now, and not quite frozen yet. I don't want to bore you guys watching this thing change phases, so it'll take about another 30 seconds, but I'll turn this off real quick, and you can see the Coke kind of disperse out a little bit from the little bit that was started to freeze up already. So I'll show you one more time how quickly we can really drop the temperature of this. It's pretty much instant. So what I'll do is we'll leave the voltage on that value that we just had it, and we'll flip this on real quick, and we'll take a temperature reading and see how low we can drop this. So Alright, let's try this. So you can see the temperature go from 70 degrees Fahrenheit all the way down to at about 32. Even well, all the way down to 20 degrees Fahrenheit. So about 12 degrees below freezing. Alright, there we go. It's good, nice. So it's pretty good. Nice temperature difference right there. It's pretty much instant cool. So this is kind of the same. It's pretty much the same device they use in those little refrigerators for your car that plug into your cigarette outlet, so they can get really cold. So that's pretty much what we're doing here. Well, thanks for watching, and let me know if you have any questions. Thanks.